Hi, welcome back to my class in Calculus 1, or this is the class in Differential Calculus. And last time we had the first lesson on the meaning of derivative. For those of you who missed this lesson on the meaning of derivative, you can search for my video in YouTube, Art Teaches Calculus 1, Lesson 1, the meaning of derivative. For lesson 2, for today's lesson, we will take up the meaning of limit of a function. It is very important for you to learn, to know the meaning of limit of a function and for you to learn how to apply the limit theorems in evaluating the limits of functions. Because initially, you will get the derivatives of functions using the definition of derivative. And in the definition of derivative of function, the derivative of function is obtained using limits. Now, what is known by limit of a function? Generally, the function is denoted by this notation y equals f of x. In this notation, the variable y is the dependent variable and it is a function of the variable x, and the variable x is called the independent variable, which means that x can be assigned any value on the domain of the function f. Specifically for our investigation, we take f of x as equal to negative 5x plus 3. We consider the function y equals negative 5x plus 3. This function is a linear function because you can see the exponent of x is 1. So this is a linear function, a function in which the exponent of any variable is 1. Now we will see what will happen to the values of y, or we will investigate what will happen to the values of the function f of x equals negative 5x plus 3. If you will compare this equation with this function notation, you can see that the function f of x in this example is equal to negative 5x plus 3. And we will now investigate the function values of f of x if we limit the values of x to a certain number. For our investigation today, we will limit the values of x to those values of x that are approaching negative 1. And our investigation will consist of two parts. For the first part of our investigation, we let x approach negative 1 from the right. The exponent positive here means that we will take values of x that are getting closer and closer to negative 1 for those values of x to the right of x. So for the first part of our investigation, we will take values of x from the right of negative 1. We will start with one specific number to the right of negative 1, and from that number we will assign values to x that are getting closer and closer to negative 1. But x will never be equal to negative 1. We only assign those values of x that are getting closer and closer to negative 1 from the right of negative 1. Hence the use of this notation, x approaches negative 1 from the right. If the values of x approach negative 1 from the right, we will investigate what will happen to the values of the function f of x equals negative 5x plus 3. Will the values of this function f of x also approach a certain number? For the second part of our investigation, we will now assign values of x that are approaching negative 1, but those values of x are from the left of negative 1. Hence the use of the negative sign as exponent of 1. We assign values of x that are getting closer and closer to negative 1 from the left of negative 1. In the diagram for the second part of the investigation, we start with an initial value, of x, a number to the left of negative 1. And from that number, we assign values to x that are getting closer and closer to negative 1. Hence, the notation x approaches negative 1 from the left. If x approaches negative 1 from the left, or through values of x from the left of negative 1, we investigate what happens to the values of the function f of x equals negative 5x plus 3. Will the function values also approach a certain number? We will find out in our investigation. We proceed with the first part of our investigation. We consider again the same function, y equals f of x. Our given function y equals negative 5x plus 3, where f of x is equal to negative 5x plus 3. For the first part of our investigation, we assign values of x that are approaching negative 1 from the right of negative 1. So we start with those numbers from the right of negative 1, and these numbers are getting closer and closer to negative 1. For the initial value of x, we start with 0. You can start with any number to the right of negative 1. You can start from 2 or from negative 1, from positive 1 half, but I will start by assigning values to x from 0. And then from 0, I will assign negative 0.5, negative 0.9, negative 0.99, and negative 0.999. You can see that these values of x from 0 are approaching negative 1 from 0. And 0 is a number to the right of negative 1. To get the value of the function f of x, you substitute each value of x to the function negative 5x plus 3. Our function f of x is negative 5x plus 3. In this function, you substitute each value of x, evaluate the function, and you get the value of the function f of x. We start with 0. If x is 0, substitute 0 for x, or you replace the variable x with 0, and you get negative 5 multiplied by 0 plus 3 equals 3. So the value of the function when x equals 0 is 3. Next, we assign negative 0.5 to x. And in this function, you substitute negative 0.5 to x, or replace x with negative 0.5. And we get negative 5 multiplied by negative 0.5 plus 3. You may use your calculator to find the value of f of x when x equals negative 0.5. And we do that. Negative 5 multiplied by negative 0.5 plus 3, and we get positive 5.5. When x is negative 0.5, the value of the function is positive 5.5. Next, we assign negative 0.9 to x, and to get the value of the function when x equals negative 0.9, we substitute negative 0.9 for x, or we replace x with negative 0.9 multiplied by negative 5 and add 3. Let's do that. negative 5 multiplied by negative 0.9 plus 3, and we get positive 7.5. When the value of x equals negative 0.9, the value of the function is 7.5. Next, we assign negative 0.99 to x, and we substitute that value in the function to get the value of the function f when x is negative 0.99. Let's do that. Negative 5 multiplied by negative 5 multiplied by negative 0.99 plus 3, and we get 7.95. Next, we assign negative 0.999 to x, and we substitute this value of x to our function f of x equals negative 5x plus 3. Replace x with negative 0.999 to get the value of the function when x equals negative 0.999. And we do that. Negative 5 multiplied by negative 0.999 plus 3, and we get 7.995. By inspection of this table of values for x and values for the function f of x, you can see that as the values of x get closer and closer to negative 1, the values of x are approaching negative 1 from the right of negative 1, from 0. These numbers are all numbers to the right of negative 1. And the values of x are approaching negative 1 from the right. And the function values or the values of the function f of x, you can see, are approaching a number. And you can see from this table that that number is positive 8. Thus, we say that as the values of x approach negative 1 from the right, the values of the function f of x approach positive 8. The number positive 8 is called the limit of the function f of x. If we limit the values of x through those numbers that are getting closer and closer to negative 1 from the right of negative 1. In symbols, we write the limit of f of x as x approaches negative 1 from the right is equal to positive 8. Or we write limit of the function f of x, our function f of x is equal to negative 5x plus 3. The limit of negative 5x plus 3 as x approaches negative 1 from the right is equal to 8 or positive 8. Again, as x approaches negative 1 from the right of negative 1 as x approaches negative 1 from the right. That means the values of x are numbers to the right of negative 1. In the table you can see 0, negative 5, negative 0.5, negative 0.9. All of these numbers are numbers to the right of negative 1 and they are approaching negative 1. As x approaches negative 1 from the right, the values of the function f of x approach positive 8. And we write that in symbols as the limit of the function f of x as x approaches negative 1 from the right equals positive 8. Or more specifically, because the function f of x is the linear function negative 5x plus 3, we write the limit of negative 5x plus 3 as x approaches negative 1 from the right is equal to positive 8. This number positive 8 is known as the right-hand limit of the function. And it is called the right-hand limit of the function f of x because we let x to approach negative 1 from the right. In the second part of our investigation, we will see what happens to the function of f of x, the values of the function f of x, if we now let the values of x approach negative 1 from the left. In the first part of our investigation, we have shown that the limit of the function f of x as x approaches negative 1 from the right equals positive 8. Or for our specific function, specific given function f of x, we have shown that the limit of negative 5x plus 3 as x approaches negative 1 from the right equals positive 8. In this first part of the investigation, we take values of x that are approaching negative 1 through values that are to the right of negative 1. In the second part of our investigation, we assign values to x that are approaching negative 1 from the left, which means that the values of x are all to the left, of negative 1. But these values of x are getting closer and closer to negative 1 from the left. And we now investigate what happens to the function of to the values of the function f of x equals negative 5x plus 3. We start with the value of x equals negative 1.5. Negative 1.5 is a number to the left of negative 1. And from negative 1.5, I will assign values to x that are approaching negative 1 from negative 1.5. We start with x equals negative 1.5, then x equals negative 1.1, then x equals negative 1.01, then x equals negative 1.001, and x equals negative 1.0001. All of these numbers are to the left of negative 1. And you can see that from negative 1.5, these values of x are approaching negative 1. For each value of x, we find the value of the function f of x equals negative 5x plus 3 by substituting each value of x into 4x into this function f of x. We start with x equals negative 1.5. Replace x with negative 1.5 to find the value of the function f. And we do that. Negative 5 multiplied by negative 1.5 plus 3. And we get 10.5. When x is negative 1.5, the value of the function is 10.5. Next, we assign negative 1.01 to x, and we calculate the value of the function f by substituting negative 1.1 for x. We calculate negative 5 multiplied by negative 1.1 plus 3, and we get 8.5. When x is negative 1.1, the value of the function is 8.5. Next, we assign negative 1.01 to x, and we replace x with negative 1.01 to get the value of the function f. We do that, negative 5 multiplied by negative 1.01 plus the constant term 3, and we get 8.05. When x is negative 1.01, the value of the function is 8.05. Next, we assign negative 1.001 to x, and we substitute that value of x for x in this function. We calculate negative 5 multiplied by negative 1.001, negative 5 multiplied by negative 1.001 plus 3, and we get 8.005. When x is negative 1.001, the value of the function is 8.005. Finally, we assign negative 1.0001 to x, and we substitute that value of x into this function. We have negative 5 multiplied by negative 1.0001 plus 3, and we get 8.0005. When x is negative 1.0001, the value of the function is 8.0005. By inspection of this table, we can see that as x approaches negative 1, the values of x are approaching negative 1 from the left, because all these values of x are numbers to the left of negative 1. As x approaches negative 1 from the left, you can see that the value of the function f are approaching a certain number. And it is evident from this table that that number is positive 8. As x approaches negative 1 from the left, the value of the function f of x equals negative 5x plus 3 approach positive 8. And in symbols, we write the limit of the function f of x as x approaches negative 1 from the left is equal to positive 8. And since our function f of x equals negative 5x plus 3, we can write this as limit of the function f of x equals negative 5x plus 3 as x approaches negative 1 from the left is equal to positive 8. Again, the limit of the function f of x or the function negative 5x plus 3 as x approaches negative 1 from the left is positive 8. This number positive 8 is known as the left-hand limit of the function, because when we get this limit of the function, we let the values of x approach negative 1 from the left. But you can see that the limit of the function negative 5x plus 3 as x approaches negative 1 from the right is 8. And this is the right-hand limit. And the right-hand limit is equal to the left-hand limit, or the limit of negative 5x plus 3 as x approaches negative 1 from the left is positive 8. We write the limit of negative 5x plus 3 as x approaches negative 1 from the right is equal to the limit of the same function negative 5x plus 3 as x approaches negative 1 from the left. Both of these limits are equal to the same number, positive 8, which means that the right-hand limit is equal to the left-hand limit, and the right-hand limit and the left-hand limit are both equal to positive 8. If the right-hand limit is equal to the left-hand limit, then we say that the limit of the function exists. Again, if the right-hand limit is equal to the left-hand limit, the limit of the function exists. But if the left-hand limit is not equal to the right-hand limit, we say that the limit of the function does not exist. The number 8 is the right-hand limit of the function negative 5x plus 3. That is the limit of negative 5x plus 3 as x approaches negative 1 from the right is positive 8. 8 is the right-hand limit of the function negative 5x plus 3. 8 is also the left-hand limit of the function negative 5x plus 3. That is the limit of negative 5x plus 3 as x approaches negative 1 from the left is positive 8. If the right-hand limit is equal to the left-hand limit, we simply write limit of the function negative 5x plus 3 as x approaches negative 1. The exponent positive or negative is omitted here, because the right-hand limit and the left-hand limit are equal. We simply write limit of negative 5x plus 3 as x approaches negative 1 is positive 8. However, if the right-hand limit is not equal to the left-hand limit, you say that the limit of the function does not exist. For lesson 3, we will take up the limit theorems, and we use these limit theorems to find the limits of function. I hope you understand the meaning of limit of a function for today's lesson. And if you have questions, you can ask your questions in the comments below. But don't forget to subscribe to my YouTube channel, Art Calizon. And thank you for joining the class today.